Hello everyone, a very warm welcome to today's topic on Bayes' theorem, which comes under the course Natural Language Processing. So let's get right into it. So first of all, the question is, what exactly is Bayes' theorem? Bayes' theorem is also called as the Bayes rule or the Bayes law. It is a mathematical formula which is used to determine the conditional probability of an event. So now what exactly is conditional probability? The probability that one event occurs given the occurrence of another event is called as conditional probability, which means that we have to find out whether the probability, what is the probability of one event, assuming that another event has already occurred before it. So if we are aware of the probability of one event, we can find out the probability of the next event that is happening. So that thing is called as the conditional probability, and Bayes' theorem helps us to find out the conditional probability of an event using a mathematical formula. It was named after the British mathematician Thomas Bayes. So Thomas Bayes is the scientist who has actually discovered this theorem. Essentially, the Bayes' theorem describes the probability of an event based on prior knowledge of the conditions that might be relevant to the event. So in short, we can also say that Bayes' theorem is basically used to describe the probability of any event given certain knowledge about the conditions that might be relevant to the event. So we have got some prior information about the event. The understanding of those prior information will help us to gauge the probability of the event occurring. So let's get into the derivation of Bayes' theorem. So as per mathematical rule for multiplication, we are aware that probability of B intersection A is equal to probability of A given B into probability of B. Similarly, by interchanging the sets, we can even write probability of A intersection B is equal to probability of B given A into probability of A. So this rule of multiplication we are already aware of. As well as we already know, according to the probability rule, that probability of B intersection A is equal to probability of A intersection B. So this is as per the mathematics formula of probability. So if we substitute probability of B intersection A equal to probability of A intersection B with the equations of rule of multiplication, we get probability of A given B into probability of B is equal to probability of B given A into probability of A. So just converting this left hand side, shifting it to the denominator, we have the Bayes' theorem, that is probability of A given B is equal to probability of B given A into probability of A the whole upon probability of B. This is the Bayes' theorem, which can also be termed as posterior is equal to likelihood into prior upon evidence, where posterior is probability of A given B, likelihood is probability of B given A, prior is probability of A, and evidence is probability of B. You can also see the Venn diagram which shows the marginal and the joint probability for the events. A and B are considered as two separate events, and A intersection B is the area which shows the conditional probability of A and B. So Bayes' theorem can be also written as like this: probability of A given B is equal to probability of B given A into probability of A the whole upon probability of B. So this is the final formula for the Bayes' theorem. Here A and B are events and probability of B should not be equal to 0. That is, the denominator should not be 0. Probability of A given the event B is also called as the posterior. Probability of B given event A is already occurred is called as the likelihood. Probability of A is the prior, and probability of B is called as the marginalization. So this is the final formula for Bayes' theorem. Let's get into an example of how Bayes' theorem can be used to solve problems. So the question is, given 80% of the time dengue causes neck pain, probability of a person having dengue is 1 by 30,000. Probability of a person having neck pain is 0.02. What is the probability that a person has dengue with neck pain? So as you can see here in the question, we have been given certain facts where it is already told that 80% of the time dengue is causing neck pain. We are given also the probability of a person having dengue is 1 by 30,000 and the probability of person having neck pain is 0.02. So on the basis of these facts, we are required to find out the probability that a person has dengue with neck pain. So let's consider A as the proposition that person has neck pain and B as the proposition that person has dengue. So according to the question, we are already given probability of A, which is 0.02, because it is given in the question probability of person having neck pain is 0.02. So we have got P of A equal to 0.02. Next, we have got P of A given B is equal to 0.8. This comes from the fact that it is given in the question 80% of the time dengue causes neck pain. So we are given already that if you are having neck pain and it is there with dengue, it is 0.8 because of 80%. Next, we are also given that probability of a person having dengue is 1 by 30,000. So that will be probability of B is equal to 1 upon 30,000. So we have been given these facts in the question and we are required to find out probability of a person having dengue given that he has already neck pain. That means we are required to find probability of B given the event A is already there, which will be calculated as per the Bayes formula. That is probability of B given A equal to probability of A given B into probability of B, the whole upon probability of A. Here we need to just substitute the values which are given. That is probability of A given B is 0.8. Probability of B is given as 1 by 30,000 and probability of A is given as 0.02. When you calculate this, you will get the answer as 0.00133. So as you can see, the solution says that the probability of a person having dengue, if he already has neck pain, is 0.00133. So this kind of problems can be solved using Bayes theorem. Let's get into the application areas of Bayes theorem. Bayes theorem is very important and has found applications in various activities including medicine, science, philosophy, engineering, sports, law, etc. I have mentioned few of them like spam filtering. Like Bayes theorem can be used to find out which mail is considered as spam based on certain words which we are already aware is generally found in spam emails. So you can filter out all the unwanted emails based on that. Here we can use Bayes theorem. Next, weather forecasting. We can find out the weather for a particular day based on prior conditions or based on prior information about the weather for the previous days. Again using Bayes theorem. We can even use Bayes theorem for DNA testing to find out the various DNA factors. Next, we can even use it in financial forecasting, like in stock markets, we can use to find out the value for a stock for a particular day based on the performance of the stock previously. We can use it for fault diagnosis in engineering. We can find out what exactly is the root cause of a particular fault in a machine. We can use it in drug testing to find out whether a drug will be successful or a failure based on the previous history of the various components in the drug. So apart from these, also there are many other example areas of application areas of Bayes theorem. So as you can see, Bayes theorem is a very important formula in mathematics which can be used to find out the conditional probability of an event given the previous history or previous conditions for that particular event in a system. So yeah, that's about the Bayes theorem. Thank you so much.